Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So today we will see the topics of tribology is friction properties of metallic and non-metallic materials. So we know the engineering tribology subject involves friction, wear and lubrication. These three parameters are very important for engineering tribology. So that whenever two components, two machine elements are in relative motion, there is a friction, and due to the friction wear will be present, and then lubrication also important. So whenever friction wear occurs, the lubrication system you have to implement so that you can reduce the friction. If friction is reduced, then you can reduce the wear also. So that you should concentrate on friction, wear and then lubrication. So already in previous sessions, the importance of friction and then the types of friction. So what is the mechanism behind the rolling friction and static friction? So already we have seen. So today we will discuss about what are the important properties of friction, of material. So which material? One is metallic material, another one is non-metallic materials. So which properties, friction properties is we should concentrate. So before designing any component, so whenever you are using two components are in relative motion, so whenever two surfaces are in contact with each other, then the friction plays important role. So that you should know about the property of particular material. So if you know the friction properties of metallic or non-metallic, you can reduce the friction. So you need to know, instead of using this material, another material you can select. Clear? So the first one is friction properties of metallic materials. So materials are two types. You know the classification of materials. One is metallic material, another one is non-metallic material. So it means one is ferrous alloys and ferrous materials, non-ferrous materials. So the friction properties we will see one by one. So these are the today's topics. So the importance of friction properties. The friction properties of metallic materials play a crucial role in various engineering applications. It may be mechanical applications, it may be electrical applications. Clear? So the friction plays important role. So influencing factors such as wear resistance, energy efficiency, wear resistance, and then energy resistance, energy efficiency, and overall system performance. So it influences these factors. So several key factors affect the friction behavior of material. So including surface conditions, lubrication, temperatures, and load. So these factors affect the friction behavior of metal. So the metal or non-metallic material behaves depends upon this surface condition, lubrication, and temperature and load condition. So what is the temperature conditions? So what is the load? So which load, how much load you are applying? So, and then lubrication system, which type of lubrication using, the surface conditions, is it smoother or harder? So, is it coated or non-coated? So, is it treated or non-treated? So, like that, the parameters are there. So, influencing this friction behavior of material. So, you will see one by one. The surface roughness. The surface roughness significantly affects the friction. So, if the surface is harder, so very rough surface, definitely friction will be more when compared to the smoother surface. The smoother surface generally exhibit lower friction coefficients when compared to the uh, harder surface. So, the typological studies often involve specifying roughness parameters such as average roughness denoted with R suffix A, and then maximum peak to valley height, that is R. So you can measure the surface roughness. So that's why in machine drawing, in mechanical engineering, when preparing a machine drawing, you should use the surface roughness values. So how much surface roughness value is using? What is the condition of the surface? You should mention in that drawing with the help of some symbols. So it's like this. You should use this suppose 0.5. So the surface. So suppose this is a machine part. Using like this. So this is on surface. It may be harder or smoother, but you can measure this hardness, roughness of the material by using this type of symbols. So that while preparing the manufacturing drawings, the surface roughness values are very important. So that you should know about the material surface finish. Next, lubrication. Lubricants can reduce friction. So already I told you in initial, whenever two components are in relative motion, there is a friction. Due to the friction, wear will be present, and then if you use lubrication, so somewhat friction you can minimize. You can't eliminate permanently, but you can minimize the friction. So similarly, if lubrication is not present, so wear will be high. So automatically the component will fail. So types of lubrication include boundary lubrication and then mixed lubrication and full fluid film lubrication. So while discussing the lubrication topic, we will see elaborately these lubrication systems separately. Types of lubrications are there. So in the boundary lubrication, hydrodynamic lubrication. So what is the mechanism behind this lubrication? We will see. So in this only the types of lubrication you should learn. Lubricants can reduce the friction whereby forming a protective film. So between these two surfaces, so suppose two components are in relative motion like this. So that in this the contact of the lubrication by measuring the alpha of film coefficient, the lubrication film coefficient, that is thin film lubrication and thick lubrication film. So the material scoring depends upon this thin film lubrication and the boundary and fluid film thickness. So you can calculate this film thickness. So different types of lubricants such as oils, greases, and then solid lubricants can be used to minimize the friction and improve the longevity of components. So you can improve the life of the component by using different types of lubricants. So these type of lubricants depends upon the type of application and type of load. Clear. So oils and greases and the solid lubricants also there. Clear. So examples graphite, semi lubricant, semi-solid, and then you can use vegetable oils, and then grease, different types of oils or SAE oils. Clear? So due to this lubrication, you can minimize the friction. Next, material hardness. So this is one type of mechanical property, the hardness. So harder materials used to have better wear resistance. So it can the harder material, it can withstand the wear. So lower hardness material not withstand the wear resistance, but may experience higher friction in this case in material hardness. Clear? So harder material tend to have better wear resistance but may experience high friction. However, the relationship between this hardness and friction can be complex and depends on other factors like surface conditions. So the relationship between this hardness and friction, so very complex. So why? Because the depends upon some factors like surface condition. So this hardness you can measure by using different hardness testing methods. Brenner hardness testing, Vickers hardness testing are there in mechanical engineering. In strength of materials lab, you can find this type of experiments. You can measure the hardness of the particular material. If you know the hardness material, hardness property, hardness value, so you may use for your desired application. If you don't know the hardness, you can't use. Next, temperature. Temperature is a very important factor. The friction properties can change significantly with temperature. The friction property also changes with this temperature. If temperature is more, so it means having more friction. If it is less temperature, so not having that much of friction. Like that, you can measure, you can determine. So the elevated temperatures may lead to increased friction due to changes in material properties and potential oxidation. So due to this temperature, the material's properties also will change. There is different types of material properties are there: mechanical properties, electrical properties, and chemical properties. So the hardness also will change, and the brittleness, and then yield stress. So that is depends upon the temperature. So that's why the elevated temperatures, the high temperatures may lead to cause a high friction. Next, metallic composition. So the chemical composition of a metal can influence its friction behavior. So every material having some composition, the carbon, silica, tungsten. So like this, magnesium. So like this, different material composition there. So for example, alloys may exhibit different friction characteristics than pure metals. Suppose if you take pure metal, so pure metal having some different friction characteristics. So take another alloy, exhibit different friction properties. Why? Because the alloy is the pure metal. There is no combination of other materials. Pure metal. So the composition is there. So the metal, the properties also will change. The composition to improve the properties of the material, you can use different metals. The combination of metals gives alloy, and then due to this alloy, exhibit different friction characteristics. So that is the alloys are used for different application, different machine elements. so that the metallic composition also influences friction. Next, adhesion and abrasion. So adhesion between contacting surfaces can contribute to friction. So adhesion is the contact between two surfaces. We have learned in adhesion theory. So this one also leads to friction. As surfaces slide or roll against each other, adhesion and abrasion process may occur. So affecting the overall friction forces. The surface slide or roll. If two surfaces are in a sliding motion, so more friction will be generated. Suppose two elements are in rolling action, so less force is required, and then automatically the less friction will be generated. So that this adhesion and abrasion these two factors affecting the overall friction forces. Clear? Just wear resistance. So wear resistance is closely related to friction properties. So in previous slide already we have seen the harder material withstand wear resistance, but having more friction, it can withstand the wear, and then friction also very high. So that's why the wear resistance is very closely related to friction. Metals with good wear resistance tend to maintain their surface integrity over prolonged periods of sliding or rolling contact. So that is the important importance of wear resistance and friction. Tend to maintain the surface integrity for prolonged periods of sliding or rolling contact. It may be sliding or rolling contact. Next, contact pressure. So the pressure between two contacting surfaces can affect friction. So it may be point contact, it may be surface contact. So the type of, according to the type of contact, there is a pressure between the two surfaces. So high contact pressures may lead to increased deformation and consequently higher friction. If the pressure between two contact surfaces, so the more pressure is there, so due to the contact, so it leads to increased deformation of the material. So material will be deformed. It may be diameter wise and length wise. So due to this deformation, high friction will be generated. So that's why this contact pressure also influences the friction. Next factor is environmental condition. So the presence of contaminants or humidity or corrosive substance can influence friction properties. So presence of contaminants means other material, any foreign material is deposited on surfaces, and then humidity or corrosive substance can influence the friction properties. It also changes the friction. It may be increase or it may be decrease. So the protective coatings or surface treatments may be applied to mitigate the effects of the harsh environment. So the protective coatings, you should protect the surface to eliminate these factors, contaminants, humidity, corrosive, and surface treatments also there may be applied to reduce the friction. So these all are comes under environmental conditions. Next one is the testing methods. Different testing methods are there to calculate the weight, to calculate the friction. So various methods such as pin on disc, ball on disc, and sliding weight tests are employed to study the friction properties of materials under controlled conditions. So under controlled conditions means under certain load condition, temperature condition. Clear? So there is a method to calculate the wear and friction. So that machine is called as pin on disc and ball on disc. So the shape of the material, the specimen is cylindrical or conical type is called as a pin on disc. So disc is always in a circular shape. Similarly, ball also, some source like this. So this is one specimen, and like this, and ball type specimen. By using different specimens, you can measure the wear. What is the wear between? Suppose we are using this pin on disc. So what is the wear between these two surfaces? So this is disc made of some material, and this one this material is, suppose example, made with another material, EN8. Clear? Suppose EN 28 this disc material, and use this pin material is EN8. So we have to we want to measure the friction and wear of this particular material. So this always this disc rotates, and then pin moves on this rotated disc. So whenever it's start to rotate the disc, the pin touches this the disc surface, and after some time, after 10 minutes or 25 minutes, you can calculate what is the wear of this specimen, how much material removed. So by seeing graphs, you can calculate the friction property and wear properties of particular material, that is pin on disc. Similarly, the ball on disc also same. If you use it instead of pin, the ball shape, so that is ball on disc. So that the ball moves on this rotated disc. And sliding weight test also there. So instead of circular motion, the sliding also there, and like this, and up and down. So all these use it to study the friction properties of materials under certain conditions. So up to now we have studied what are the friction properties of metallic materials only. Next one is friction properties of non-metallic materials. Some factors are same as the metallic materials only. So different properties are there. That is the properties exclusively for these non-metallic properties. So friction properties of non-metallic materials are essential considerations in various engineering applications, same as in metallic materials. So including those involves the engineering applications here, polymers, ceramics, composites, and other non-metallic substances. The friction properties of non-metallic materials are considerations in engineering applications, but it includes some involved polymers, ceramics, composites, and other non-metallic substances. Similar to metallic materials, the frictional behavior of non-metallic materials is influenced by several factors. Already I told you, many factors are there. The same as metallic materials, similar to the metallic materials, the friction behavior also will depends upon these factors. So here are some key aspects to consider. We will see. So one is surface roughness. In surface roughness, factor is in a metallic materials also there, and same factor influence the non-metallic material also. So surface roughness plays an important role in the frictional behavior of non-metallic materials. Not only non-metallic and metallic materials also it plays very important role. So similar to metal, smooth surfaces generally exhibit lower friction coefficients when compared to the harder surfaces. Next one is material composition. So material composition of non-metallic materials including polymers, ceramics, and composites. So these materials greatly influences their friction properties. So different polymers, for example, may exhibit varying coefficients of friction based on their molecular structure and chemical composition. Different polymers, for example, different types of polymers exhibit various coefficients of friction. So that also based on the molecular structure of the particular material and what is the chemical composition of the material. Based on these molecular structure and the chemical composition, they vary the coefficient of friction. The coefficient of friction mu value depends upon these two structure and the chemical composition. Next, temperature. The temperature can affect the frictional behavior of non-metallic materials. The same as metallic materials. So, impacting factors such as material softening, changes in viscosity for polymers, or phase transition in certain materials. So due to this temperature, phase transitions will be possible, and viscosity changes in viscosity also will be present. Material softening. So all these affect the frictional behavior of particular material. Next, load and pressure. So non-metallic materials may exhibit complex load dependent behavior, with friction increasing or decreasing depends upon the applied load and pressure. So already I told you in metallic materials case, so the friction value or behavior of the material, the friction behavior, it depends upon these two. Load, how much load you are applying, and how much pressure between these two contact surfaces. So more contact is there, suppose between two surfaces, more friction will be generated due to the more pressure. Similarly, applied load also. Light load, medium load, and high load is there. So if we are using high load, there will be more contact between two surfaces. Due to this contact, more pressure will be present. So automatically what will happen? So due to the whenever high pressure will be present, there is a high friction. Next, lubrication, same as in metallic materials. So lubrication also important for non-metallic materials. Some polymers may self-lubricate, while others may require external lubrication to reduce friction and wear. So actually, some polymers may having self-lubrication. No need to use separate lubrication system. The material itself giving lubrication property. So while others may require external lubrication system to reduce the friction and wear. So externally, the oil is required to pump into that relative motion parts so that we can reduce the friction. So example, engine piston. So always it moves top dead center to bottom dead center in the cylinder. So requires lubrication. Why? Because here two motions are in contact surface. Piston material and then cylinder material. So automatically, whenever you are pumping, you are supplying external lubrication. The lubrication will be present these two contact surfaces. It leads to reduce the friction between these two components and wear also. Next one is moisture and environment elements. So moisture and environmental conditions can significantly impact the friction properties of non-metallic materials. So environmental conditions means temperature and humidity. So impact the friction properties of non-metallic materials. For instance, some polymers may absorb water, leading to changes in their mechanical properties and friction behavior. So polymers may absorb water. So due to this absorption of water, the changes in their mechanical properties. Many mechanical properties are there: strength, hardness, creep, ductility, malleability, creep. So like this, many mechanical properties are there. So it leads to changes these mechanical properties, and so automatically the friction behavior also will be changed. Next, wear resistance. So non-metallic materials may exhibit wear mechanisms different from metals. Wear resistance is a critical factor in applications where non-metallic materials are subject to abrasive or erosive conditions. Next one is composites and reinforcements. So non-metallic composites, which often involve combination of polymers, ceramics, and other materials, may have unique mechanical friction properties based on the type and arrangement of reinforcements. So non-metallic composites. So it involves combination of polymers, ceramics, and other reinforcement material. Suppose here cement and mild steel rods are there. So like this, steel rods. This is cement and steel rods or iron rods. So this is one type of reinforcement method. So in this arrangement, the combination of this structure having two materials, one is cement and another one is steel. So the type of arrangement of reinforce also affect the friction behavior of the material. If you arrange the reinforcement in a systematic way, uniform space, and if you arrange the reinforcement material in zigzag manner, so according to this, the behavior also will be changed. So here reinforced material is steel rod, and then the material is other material is the combined material is cement. Another one is testing methods. Similar to the metallic materials, non-metallic materials are evaluated using various tribological tests, such as pin-on disc. Already we have discussed in a previous slide, and ball-on disc test to quantify their frictional behavior under controlled conditions. So not only for metallic materials, you may use non-metallic materials to find out the frictional behavior and wear testing by using ball on disc or pin on disc machine under certain conditions, controlled conditions. So these are the various factors affects the frictional behavior of non-metallic materials. Another one is surface treatment and coatings. So surface treatments and coatings can modify the friction properties of non-metallic materials, providing enhanced wear resistance or tiled friction characteristics. You may enhance the wear resistance by using some surface treatments and coatings. So by suppose if you have used these type of coatings, the friction properties may be changed. For improvement, to enhance the wear resistance, to enhance the frictional characteristics, finally the ultimate aim is to reduce the friction to minimize the wear. So that's why you should use the surface treatments and then coatings. You have to apply some coatings on contact surfaces. Next one is the coefficient of friction. The coefficient of friction is a key parameter. It may be metallic or it may be non-metallic materials. So it characterizes the frictional behavior of material. So non-metallic materials can have different coefficient of friction values depending on factors such as surface roughness, temperature, and humidity. So that the coefficient of friction is important factor in metallic materials or non-metallic materials. So that the values depending on surface, depending on factors such as surface roughness, temperature value, and humidity value. So based on this surface roughness, temperature, and humidity, the value may be changed. So the coefficient of friction value is not constant for all materials. It may vary. With all these factors affecting the frictional behavior of the material. So that when selecting non-metallic materials for specific application, it is essential to consider these factors and conduct thorough testing to ensure that the chosen material meets the desired frictional requirements in the intended environment. So this is the final conclusion of the frictional properties of non-metallic materials and frictional properties of metallic materials. Why should we learn these frictional properties of materials? If you know the material, so you can select better material. So it gives better life. It will withstand all type of resistance. If you have selected wrong material, so without knowing the frictional properties, then automatically the design will be fail. So that whenever you are designing a component, so whenever using two surfaces or two elements are in a relative motion, so whenever you are going to uh, put two components in contacting nature, so there, for specific application, there it's essential to consider all these factors. And thoroughly you should conduct the wear resistance, wear calculating mission, and they conduct the wear properties, conduct the friction properties. So then only you can use the proper lubricants to minimize the friction, to minimize the wear. So these are the references I have taken. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.